Hello and welcome. My name is Mr. Giovanelli. Most of you know that already, but in case you're watching this from another teacher's class, welcome to this review on triangle similarity for your lesson today. I'm using something new called paper tubes, so bear with me as I kind of work out the kinks, but I'll do my best to do it right and make it quick for you. So let's get into it. All right, big idea here. Similar triangles. What are the qualities of similar triangles? Triangles are going to be similar if one of these two conditions are met, because if one is met, then the other is also met. Triangles are similar if corresponding angles are congruent. So that's our first quality here. Corresponding angles are congruent. And then also if corresponding sides are proportional. Okay, so we're looking for those two things. We'll talk about what each of those things here is in a minute. Let's take a look at this situation here. This triangle DEF is being dilated from the center of dilation to form ABC. So let's see both of these qualities in action. You can notice here that the common angles are the same, so the corresponding angles are congruent. And then when we say the corresponding sides are proportional, what we mean is that they are getting bigger or smaller by the same rate. So since this was the original and it's dilating into this triangle, you can see that it's getting smaller by 1/2, and that's consistent here as well. So that's what we mean when by the sides being proportional. Okay, now to calculate that scale factor, I know I kind of went over that kind of quickly, but a quick review on calculating scale factor, which we call R, sometimes K as well, is we'll sometimes say you take the new distance and divide it by the old distance. Okay, so in this case, let's just take one example here. In this case, if we took AC and divided it by its corresponding distance, DF, then you would have 8/16. So then we would know that the scale factor here is 1/2. All right, so that's not a 2. So that's a quick little recap on, there you go, 1/2. It's a quick little recap on scale factor and dilations and what similarity is. Let's go on to the next page here. Okay, let's look at 3 ways to prove triangles are similar. The first one is through the AA criteria. So AA, like it sounds, is for angle, angle, and this is where we're looking for 2 angles in common. So here you can see we have the 102s in common. We don't have the 30 and the 48 in common, but let's check using what we already know about triangles. We know that the triangles are going to add up to 180. So add these up. That's 132. Subtract that from 180. 180 minus 132, and that's 48. So you got there the second angle in common, and if 2 angles are in common, then actually really all 3 are in common. That would be 30 also. Okay? There's one other way this can show up, a little more advanced. If we look at this a little too quickly, we might say, well, this is only 1 angle in common. These aren't similar. I'm moving on. But we have to remember other things we've learned. And you can probably already see here that in the middle, these are vertical angles. So even though I don't know their degrees, I know they have the same measurement. So I would also be able to say that these 2 triangles are similar because of the AA criteria. So a couple different ways AA can show up. Moving on down here to the side, side, side criteria. So side, side, side means that all the sides are proportional. So what we want to do here is we want to check the proportionality of each side. So I'm going to take the small side here, so that's the 14, and compare it to the smallest side here. And it doesn't really matter what I consider the new or the old as long as I'm consistent. So I'm going to consider this first triangle on the left the new. So I'm going to say 14/10. That's the scale factor I'm going to test. Now before I even mess with that, I'm going to test the other numbers too. Let's go 21 over the middle value here is 15, so this is going to be 21/15. And then let's test the largest values, 28/20. All right. And what I want to see is I want to see all these numbers come out to the same number. That means that the triangles are proportional. So if I plug these into my calculator, imagine I just plug them into my calculator, you would get the same number each time. If you don't believe me, you can definitely do it yourself, but you would get 1.4. So because the scale factor is consistent all 3 times, That's SSS similarity. So these triangles are similar because of SSS. Okay? The third and final similarity criteria is kind of a mix of those two. It's called the SAS criteria. So the SAS criteria, notice it deals with sides and angles, two sides and one angle. So let's take care of the sides first because that's the clearest to see. This side, 4 is becoming 8, so you can see the scale factor there had to be 2. All right, and then down here, 3. Ooh, I gotta get better at this. 3 is becoming 6, so you can see the scale factor is also 2, right? So we have a common scale factor. I can't call it SSS though because we don't know the third side. So it's still just SS right now, but notice here, let's change to a different color. Notice here that we have a common angle here. And equally important, not only do we have a common angle, but that angle is right in the middle between the two sides. That's why we call it SAS, with that A right in the middle between the two sides. So under this condition, the triangles are also similar. That's SAS similarity. If the angle's in common between the two proportional sides, it guarantees that this side is also proportional. Okay? Now let's apply that to find a missing side of a triangle, and then we will be done. So here we go. You have two similar triangles here. You have a 90-degree angle in each of them, and then you also have this angle A in common due to the reflexive property. That's the same angle on both. Now I'm saying both. There's two triangles here, so let's make sure we see the two triangles. So the first triangle is the smallest one. You can probably see that one, where you have the 6 and the 0.9, right? The second triangle is the larger triangle, which I'm not very good at drawing triangles on this yet. I'm going to get better at that. But this is what we're actually looking for. We're looking for H here. And then this side is supposed to represent AD. Now, a lot of students here, they're going to make a common mistake. They're going to call this 12. Very tempting to want to call that 12. But 12 does not represent this whole part, right? This whole part is actually 6 plus 12. So let me do some erasing here. That's not 12, that's actually 18. So when I'm doing my scale factor, what I want to do is I want to say, okay, I'm going to compare that 6 on the small triangle to that 18 on the large triangle. So I've got a scale factor, let's see, 18 divided by 6, that's 3. So I've got a scale factor of 3. So that means to figure out H, I'm going to take 0.9. I'm also going to multiply that by 3. 0.9 times 3, it's like 9 times 3. H is going to be 2.7 meters. Okay, so just quick recap. Don't forget to add, if you have overlapping triangles, don't forget to add this whole length. That's how we got that 18. Then I compared the 6 and the 18 to get a scale factor of 3. And then I applied that scale factor to find the missing side. Okay, I hope that helps you with your assignment today. Please reach out to me or any of your teachers if I'm not your teacher to get your questions answered, and have a great day. Take care.